Hello and Assalamualaikum. My name is Imran Ismail. My matrix number is AA2047 and here is my other group members, which is Muhammad Qayyum bin Zulkifli. Matrix number AA200-546, Muhammad Faiz Fahad bin Wahizam, AA201169, and lastly is Muhammad Fadlan Hazim bin Khairul Fazilah, AA200 and 200. All of us is from section 5. So in this project, we need to complete the task given by the lecturer. The task is to do more analysis or study about the stability and PID controller. In this project, we need to able to analyze on how the system becomes stable, and if the system are not stable, we are the action needs to be done. They are the action need to be done. We are needed to use MATLAB software and personal provision for these assignments. All groups members are participate in this project. Problem statements. We are given 3 objectives in this project. The first objective is to determine stability of a closed loop control system using pole zero plot. The second objective is to stimulate the closed loop system to obtain the step response, and the last objective is we need to implement P, PD, PI and PID controller to meet control system design requirements. All of these objectives must use all 4 closed loop system given. So this is all 4 closed loop system given by the lecturer. So for the result, objective 1 determine stability of closed loop control system using pole zero plot. For the first closed loop system, the TS that we found from the calculation is 1 over S to the power of 2 plus 1. So the 0 is 0 and the pole is I and minus I. So when we write the equation in the MATLAB software, as shown in the picture here,
Anytime now.
run it so we can get the pole zero mat
I'll
graph.
be digging into this mouth-watering nasi lemak.
So basically the first system is
Biting into a
stable,
couple of juicy
and the
burgers.
second system,
A freshly made poke bowl.
after
Crispy
calculating
Korean
to find the TS, we got
A
the
delicious
answer
bowl
is
of
20 over S to the power of 2 plus 25
Order from a
plus
variety of your
29.
favorite restaurants.
So the 0
Only
is
with
0
Grab
and the pole
signatures.
is minus 1, negative 1, positive 5.29i and negative 1, negative 5.29i. In the pole zero plot sketch, here is the answer. So in the MATLAB software, if we write the equations, it should be like this, and this is the result for the pole zero maps. So the second system also stable. For the third closed loop system, after doing calculation, we find out that TS is equal to 250 over S to the power of 2 plus 45 plus the 300. So the 0 is 0 and the pole is negative 2, positive 17.2i and negative 2, negative 17.2i. So if you are plotting from the sketch here, the answer. Now let's compare to perfect answer. So for the third system, if we write the equation in the MATLAB software, it should be like this, and we got the pole zero map from the equation. So the third closed loop system is stable. For the last closed loop system, after doing some calculations, we find out that S is equal to negative 2. So the pole is negative 8.052 and 1.026, positive 8.571i and 1.026 negative 8.571i. When we sketch the pole zero plot, it should be like this. And for the confirmation, let's write it in the MATLAB equation, should be like this. And we can get the pole zero map. So basically, the fault closest system are not unstable. So thank you. We'll pass out to the next video. Thank you.
Okay, next. My name is Muhammad Faiz Farhan bin Hazam and my number metric is AA201169. So now I want to explain about objective to simulate the closed loop system to obtain the step response. So now I want to find the stable, unstable, marginally stable, overshoot, rise time, settling time, and steady state error. Okay. This given is closed loop system 1, closed loop system 2, closed loop system 3, and closed loop system 4. So we have 4 system closed loop to find the overshoot, rise time, settling time, and steady state error. Okay, firstly closed loop system 1. So this is a graph, the result from MATLAB closed loop system 1. This the closed loop system 1 is marginally stable. And next, closed loop system 2. This is a graph for closed loop system 2. And then so now I want to explain how to find the overshoot, calculate overshoot. Okay, firstly the formula to calculate overshoot is max value minus final value over final value times 100. And then for the closed loop system 1, max value is 1.053 minus final value is 0.16897 over final value 0.16897 times 100, and we will get 0.68%. Okay. Closed loop system 2 steady state error. We need to change the step to RAM, and then add a mux for the find the steady state error, and then you run the simulation and we will get this graph. Okay, next, closed loop system 3. After you make a closed loop system 3, and then you run use the MATLAB to run the system, and then you will get this graph. Okay, to calculate overshoot MP, overshoot max value minus final value over final value times 100. For the closed loop system 3, overshoot max value is 1.400 minus final value 0.8312 over 0.8312 times 100, and we will get 68%. Okay, closed loop system 3 steady state error. Okay, same like closed loop system 2, you need to change the step to RAM, and then add the mux. After you change the circuit, you running the circuit, and we will get the graph. Okay, closed loop system 4. This is a closed loop system 4. After you running the circuit, and you will get the value at the table. Okay, closed loop system 1 marginally stable and don't have overshoot, rise time, settling time, and steady state error. What about closed loop system 2? The graph is stable and overshoot is 52.68%, and rise time is 0.4533 seconds. And about settling time for closed loop system 2 is 3.857 seconds, and steady state error for closed loop system 2 is don't have. And next, closed loop system 3, the graph is stable and overshoot is 68%, and rise time is 0.2256 seconds, and settling time we will get 1.830 seconds, and steady state error we will get the result. And closed loop system 4 is unstable. Okay, thank you, that's all for me.
now I will present about objective 3 or closed loop system 1 and 2. So the objective is to implement PPD, PI or PID controller to meet control system design requirement. So according to our table 4.3.1, the design requirement should be overshoot percent equal to 10 or less than 10. Settling time or TS is equal or less than 5 seconds. Steady state error percent is equal to or less than 2 seconds. So this is the closed loop. This is the closed loop system 1, and this is the block diagram without the controller. So this is the block diagram after we add the PID controller. So for the parameter should be the proportional 100, the integral 40, derivative 30, and lastly filter coefficient should be 100. Then we will apply this to the PID controller and we will get the result, which is the graph of the block diagram with PID controller. So the characteristic of the graph with the PID controller for system 1 is overshoot 9.251%, setting time is 3 seconds, and steady state error is 0%. So for closed loop system 2, this is the block diagram and this is the result without a controller. So for the graph, the block diagram without a controller, and this is the block diagram with the PID controller. For the parameter, we will set the proportional to 10, integral to 6, derivative to 2, and filter coefficient to 100. We will apply it to the controller and we will get this result. So the characteristic of the graph with the PID controller is overshoot 8.5%, setting time is 3.5 seconds, and lastly the steady state error is 0%. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadlan Hazim bin Fazilah. My entry number is 200. Okay, I will present to you about closed loop system 2. Okay, this is the block diagram without controller. And this is the result, which is graph of the block diagram without a controller. This is a block diagram with the PID controller, and this is the parameter of the PID controller, which is proportional is 11, integral is 10, derivative is 1, filter coefficient is 1000. Is graph of the block diagram with PID controller, and characteristic of the graph is overshoot 3%, setting time 0.0315 seconds, and steady state error 0%. For the closed loop system 4, this is the block diagram with the controller, and this is the result, which is the graph of the block diagram without a controller. And this is the diagram with the PID controller, and this is the result, which is graph of the block diagram with PID controller. And the characteristic of the paragraph of the graph with the PID controller: overshoot 10.5%, setting time 2.52 seconds, steady state error is 0%. So the conclusion from the project is all the main objective achieved by the end of the module. There are 3 main objectives that has been achieved after completing the module. Those are stability of a closed loop control system using pole zero plot is determined. The second, the closed loop system to obtain the state response is simulate PD, PID controller to meet control system design requirement is implemented. So that's all from me.